Hi everyone, in this video we are going to be talking about SI units, prefixes, and conversions. SI is our system of internationally used units for scientific measurements. So when measuring length, we are going to be measuring it in meters, and that symbol is going to be M. For mass, it's going to be kilograms, temperature is Kelvin, and time is in seconds. For the sake of chemistry, just be aware that these exist. We don't really care about these too much. However, if you are in physics, I would become very, very, very familiar with these units because that is how you are going to get pretty much every other unit that you're going to use in physics. For chemistry, however, I would really just focus on temperature is Kelvin. Most people have heard of Celsius and Fahrenheit, and then to convert between the two, there is a formula, and this will have to be given to you. You don't have to memorize that formula unless your teacher specifies otherwise. Kelvin, however, I think you need to memorize this because we are going to be constantly doing Kelvin to Celsius, Celsius to Kelvin. So if we were to do Celsius to Kelvin or Kelvin to Celsius, the only difference is that with whatever Celsius is, you're just going to add 273 degrees, and this is going to give you whatever your temperature is in Kelvin. If you were told that you have something that is 25 degrees Celsius and you need your units in Kelvin, all you're going to do is add 273. This is going to give you 298 Kelvin. If you are given something is 300 Kelvin and you need to find this in Celsius, you're just going to subtract 273. Now you're going to have 27 degrees Celsius. This is going to be really important moving forward because based on whatever constants we're given, we'll see whether we need it in Celsius or Kelvin. And this is just something that you're going to have to do a lot. So for the SI units, for the sake of chemistry, just be aware that they're there and that they exist. Maybe for exam 1, quiz 1, you might see questions about this. We don't really care about it for the rest of it. Physics, definitely make note of these. Prefixes are going to be placed in front of any unit of measurement to represent something that is very big or very small. These are their names and symbols, and then their factors and numerical values that they represent. I'm sure that we have all heard of something called a gigabyte. Gigabyte. Well, a gigabyte, byte is our base unit. Giga is just the prefix. There are 1 billion bytes in 1 gigabyte. You're not going to say, oh, can I have 10 to the 9th bytes for my phone storage? No, you're just going to say, can I have X amount of gigabytes? I'm also sure we've all heard of kilometers. We've all heard of centimeters, milliliters. It doesn't matter what unit we put it in front of. It can go in front of bytes, meters, grams, liters, seconds, really anything. Now, for the sake of all chemistry, physics, and any future math courses that you're going into, I do not want you to focus on the numerical values. If we look at kilo, it's like 1,000 grams in 1 kilogram. A lot of people will multiply or divide by 1,000. I don't want you guys to do it. I want you to get into the habit of multiplying or dividing by 10 to the third. I would become very familiar with the prefixes kilo, milli, and then if you are in physics, I would also become very familiar with micro and nano. These, I think, are the most important ones. You do need to use like nano and micro once in chemistry, but otherwise, I would really just focus on kilo and milli. So 1 kilometer is 10 to the third meters. This is my shortcut. Ready? If we have 270 kilometers and I want this in meters, all I'm going to do is just do 270 times 10 to the third meters. Boom, that's my conversion. It's done. We can say that 987 milliliters. If I want this in liters, I just do 987 times 10 to the power of -3 liters. That's how simple it is. So this works because of dimensional analysis. If you haven't watched my dimensional analysis video, I highly recommend going and watching that. but it works. I'm going to use 270 kilometers just as an example. With dimensional analysis, whatever you want to cancel goes on the bottom. We are going to use this as our conversion factor. We want to cancel kilometers. We want to cancel that. So we are going to put it on the bottom. And we want to be left with meters, and we are going to put that on the top. So we have 1 km on the bottom and then 10 to the power of 3 meters on top. This cancels, and we are left with meters. This just leaves me 270 times 10 to the third meters. However, if you want to go from a base unit and add on that prefix, you are going to have to flip the sign of the exponent. Let's say I had 492 grams, and I wanted to know how many micrograms this is. Using dimensional analysis, I put whatever I want to cancel on the bottom, and I want to get whatever I want on the top. In 1 microgram, and so when we're using micro, this sign, it's called mu. As you can see, we already have capital M taken by mega. We already have lowercase m taken by milli. So that is why the micro uses the, I think it's Greek letter mu. Okay. 1 microgram is equal to 10 to the power of -6 grams. This is my conversion factor. I'm going to put 10 to the power of -6 grams on the bottom and 1 microgram on top. Again, dimensional analysis, this cancels out and we are left with micrograms. When we have an exponent on the bottom, all we have to do to get it on the top is just flip whatever sign it is. This is going to leave me with 492 times 10 to the power of 6 micrograms. That is how we do conversions the opposite way, going from our base unit to something with a prefix. That is it for this video. I hope that this made the idea of conversions a lot easier to digest and a little bit less daunting because there is going to be a lot of this in any STEM field. I will see you all in the next one.